Yeah, captures the video and the mic. Great things. All right, last talk of the day: how to build a secure login page. I guess Ben Broussard, he's been involved in the Austin OWASP chapter since 2008, giving technical talks, serving on the LASCON board, the chapter board, and organizing the study group. Outside of OWASP, he has worn the hats of mainframe and web app developer, cryptographer, pen tester, and he launched his own application security business, Cadallion Security, LLC. On the side, he does research into brains and AI, logic and mathematical puzzles, and is an avid 80s dancer, which is the last 15 minutes every time. Okay.
This is how to do the one. You're all here for that, right? You are going to demo it now. Not on floors as hard as this. All right. Everybody hear me just fine? Too loud, too quiet? No? Perfect? All right. Yeah, I'm Ben Broussard. I am an 80s dancer. You'll catch me downtown if you go on Friday, 80s Dance Night, Barbarella's. Anyways, let's talk today. Bound to be a little sleepy. I'll try to keep it lively. When we get to the attack section, which is the second half, it's a lot of fun. We talk about some examples of real attacks, ways to win, bidding on eBay, fun stuff like that. So, enough to keep you awake. If it's not, feel free to go to sleep. All right, or you know, you can also get excited because the mechanical bull is going to be here after this talk, and the bar will be open. So, a lot of things to look forward to here at LASCON. All right, how to build a secure login. So, quick poll: who here is a developer? Awesome, you are too, Carl. All right, well good, because that means that I can kind of speak more freely about the technical side of things going on. This talk is broken down into two sections: how authentication works, take you through kind of what I see as the 5 sections of that, and then we'll go into the attacks and defenses on each step. So let's do it. All right, the pre-login section. 5 sections: pre-login, the login page, the login redirect, the logged in section, and logout. So in the pre-login section, users get to the site in a bunch of different ways. They don't just put the URL into the URL bar on their browser. They can also get there from a search engine, from bookmarks they have, links from emails, iframes on other sites. And I'm going to talk briefly about the request response model of the internet, but since so many of you are developers, most of you probably have a good grasp on that, which is good because it's required to understand a lot of these attacks and defenses. So in the pre-login area, you don't have any validation of who's who. So you can't really complete a lot of actions, but you can usually start actions. If it's a shopping cart application, you can usually add stuff to your shopping cart. So there's a lot of pre-login actions that can actually be done, and we'll talk about the attacks on those later. Also, 2 things that are in the pre-login area are account creation and password reset. And those are fun to attack. The request response model: if you pull up an HTTP proxy like Burp Suite or Web Scarab or Foxy Proxy or Firetabs, or there are a bunch of them, you'll see the actual text that's going by in the request and the response. HTTP is just text. You've got, this is an example, get request. Request goes from the client to the server, response comes back. The response contains some headers such as a set cookie header. That's an important one. That's really the most important one. It also includes an HTTP code like 200 OK or 302 found, which redirects you. But yeah, this is the request response model. All right, the login page. Are we getting a little static here? I'll put a leg up. Okay, it's working. All right, the login page. Users can get to the login page in different ways. They can click on the login link. They can also attempt to go to a logged in page without being logged in. Often this is when they bookmark a page that's an authenticated page, and then they try to go back to it a week later. And they can also make a request to a logged-in page after the session has expired. This happens a lot on long forms where you're filling out the form, takes you an hour to fill out, you hit submit, and you're no longer logged in. Login page needs to know where to send the user after a successful login. So this is necessary input into the login page. It needs to know, once you have submitted valid credentials, where to redirect you to. If it doesn't know that, where's it going to send you? Not back to the login page, right? So input to the login page includes a bunch of stuff, more stuff than just a username and password. It also often has a pre-login cookie, which might have a tie to the cart details if it's a shopping cart-like application, or if it has any pre-login functionality. Also, anti-cross-site request forgery tokens are common. CAPTCHAs are sometimes there. Sometimes there's a second factor, RSA tokens, something like that. So here are the two setups. One, you click on the login link, and the request goes from the client to the server. The server returns the login form and the response. The other way is when you've been logged out from inactivity, or you try to go to a logged in page but you're not actually logged in. You get a 302 found response. So you make the request to the logged in area, you get a 302 found response, your browser processes that response. In a 302 found response, there is a location header, and that location tells your browser where to redirect you to. So it redirects you to the login page, and you make a request for the login page, you get back the login form. Here is it's in more detail. You don't necessarily have to be able to read all of that, but I'll go through it briefly. You make a request to the login page, or to a logged in page. In this case, it's mail/inbox.php with email ID equals 11 and action equals mark as read. So you're marking the 11th email as read. You're trying to do that, but you've waited too long, and so your account is inactive. You get a 302 response. It contains two important headers. It contains other headers as well, but two that are really important for the login functionality, which is a set cookie header. So this always comes in a response. A request header might have a cookie. A response header might be set cookie. So here it's setting the cookie go to be what you were trying to do in the first place. And then it's a 302 response, so it redirects you to the login page. Third action here is you make a request to the login page. Fourth, you get the login page back. Fifth, you send your credentials on. So that's the fifth one here, the last one. And along with your credentials, you often also send cookies, such as an anonymous session ID and a go-to or a directory or where you were trying to go in the first place cookie. Sometimes that's a cookie, sometimes that's a parameter that gets put in the post body of the request. All right. Then there's this login redirect, this invisible part that most people don't see in a login setup, but it is an important part. It's a very important part because it's what happens directly after validation of a user's credentials. After the user's credentials are validated, there's a redirection response which contains the set cookie header for your session cookie. So this 302 response also contains a set cookie header, and it has your session cookie in there. It's set for you. It's usually a 302 response. Sometimes it's just a 200 OK response. Again, it includes that set cookie header, but it redirects you to where you're supposed to go in some other way. Either it's using a JavaScript redirect or a meta tag redirect. Those are the main ways to redirect someone. And like I said, the new cookie is the logged in session cookie. All right, so here it is broken down, 3 parts. First, the response from a successful login. So in the previous steps, we submitted our login credentials, username, password. They were valid. And so we get back a 302 found response with a session cookie being set. You might notice that there are some other pieces to a session cookie, such as the path. You can also have a domain attribute. And there are two flags here, secure and HTTP only. Secure means that the cookie will only be submitted over SSL, requests that you make over SSL. And HTTP only means that JavaScript won't have access to this cookie. So JavaScript code won't be able to say document.cookies and see the cookie there. So your browser gets back that 302 found response, and it does what browsers do. It processes that, and it goes to the location it's told to. And so you make a new request to mail/inbox.php with email ID equals 11 and action equals mark as read. And you send the cookie with this new request. In fact, from now on, every request you make to the appropriate domain and path, and possibly with some SSL restrictions, contains the cookie. This is something done automatically by your browser. After you log in, every request that you make to that domain contains your session cookie. This is how login is maintained. That's it. That's all the information. It's not very common for servers to look at things like what IP address is this coming from or any information like that. It's usually just what cookie value are they giving me. Okay, that's tied to some session that I have stored. So the cookie is the person, is the browser. And then a response comes back from the server with the resource they were trying to get to in the first place. So now they're logged in, and they have access to sensitive data. They can take powerful actions. They can do all sorts of stuff. It's logged in. It's the juicy part of the application. Like I said, the user stays logged in because the browser adds the cookie header with every request to the appropriate domain and path with flags and such. Was there a question? Often users have to fill out long forms that take longer than the inactivity logout period. And that's tricky because forms do a post request, and a post request has all the details that you put in there. Just like when you log in, it has a post body. So it has, when you log in, it's username and the equals and whatever username you have, then an ampersand, password equals whatever password you have. When you get logged out and then logged back in, the 302 redirect just has a location header, just has a URL to send you to. So you try to post that long form, but instead of it actually going through, you're redirected to the login page, and then after you log in, you're redirected back to the form you were trying to post, but without all of the post body details being posted. So maintaining post information across login is actually a difficult, quite a difficult task. Actually, Carl and I sat in a meeting one time to try to figure that out at UT, and I don't think we got anywhere with it. We had some ideas, but it was difficult to implement. That's one way. How long? Exactly. But I mean, yeah, it's how far do you push that? You know, there are some cases you can say push it 8 hours. Everybody works from 9 to 5 or something like that. Those cases might work. Other places you don't really have a time window that you can limit it in. You might have forms that somebody has to have up and submit irregularly. So it's in some cases you can just increase the timeout, but in many cases there's not a good number to increase it to. But yeah, we've got developers in here, so we've got people who are like, well, what about this? Isn't this a solution? I like to hear that. That's good. So another tricky thing with the logged in area is users might have multiple tabs open. They might be doing multiple processes at the same time, so it's difficult to try to keep an order to things. You might have something where you expect somebody to go through a process like a checkout process. Say it has 5 stages. Well, when they're in the 3rd stage, they might have another tab open at their cart, and they might change their cart details and then go to the 4th stage and then finish the checkout. How that's handled can work in different ways. Here's an example of a valid request and response during the logged in area. It's a request to payroll/directdeposit.php. It's a post request. It contains the session ID cookie because it's to the valid domain. And it has a post body, routing number, an account number, and a cross-site request forgery token. And the response that comes back is just a 200 OK, and then whatever web page comes back. Logout. All right, this is the last bit of just kind of background. Here's how it all fits together, and then we're going to go into attacks. In the logout area, users get logged out in different ways. They might click on a logout link. That is not very common for users to actually do, but some people do it. Their session might expire due to inactivity or absolute timeout. They might complete an action. Some sites, you get on the site, you log in to complete an action. Once you're done with that action, you're automatically logged back out. Or they might navigate to a non-logged in section of the site, or particularly the login page itself will often log people out because it sets a new cookie. So there are, again, kind of two ways that this happens. In one case, the person clicks on the logout URL. They get a 302 redirect, which contains usually a set cookie for the session ID cookie, and it changes the value or it changes the expiration time to sometime in the past in order to make sure that they don't have the correct session ID on their browser anymore, so they actually stay logged out. And it usually has a location header as well, which sends them to a default landing page for the site. When you click on the logout, you're redirected somewhere general, some non-logged in area. When you get logged out due to inactivity, you usually try to make a request to a logged in page, and you get redirected to the login page itself. So again, the 302 usually has a cookie, the session ID cookie. It updates that in some way to make sure that your browser no longer thinks that it's logged on. Another side to that is on the server, it should be disabling the session that's tied to that cookie. All right, the fun stuff, attacks. All right, so what are the goals of an attacker when it comes to the authentication piece of an application? Obvious goals, they want to bypass login. They want to log in as a different user. They might want to force logged in users to take actions. They don't even need to log in if they can do that. They might want to get logged in users' information. Affecting pre-login actions that affect logged in actions. I call that like a carryover attack. Usually the pre-login area is less secured than the logged in area, but if you can affect the pre-login area, you might be able to have some type of effect on the logged in area. For instance, with a site like Etsy or Amazon, if you're selling your stuff on there and you can get everybody to add one of your items to their cart, then some percentage of them won't notice and they'll end up going through the full checkout and you'll have a whole bunch of people buying your stuff. And it's not something that it's not that you attacked them while they were logged in. You attacked them while they weren't logged in yet and they were just browsing around on the website. So it's kind of a pre-login area. The attack gets carried over. You might want to get users to log into a known session or account. That's a little trickier. We'll talk a little bit about that coming up. Getting valid usernames, passwords, email addresses, those are common. And locking out users is sometimes just mean, but sometimes has really useful effects for an attacker. All right, so how do the attacks fit into the pre-login area? SQL injection. SQL injection gives you an attack vector at the underlying database. Well, the logged in area and the pre-login area probably share the same database, or at least the same database server, and you might be able to hop databases. So protecting against SQL injection in the pre-login area is just as important. It's also probably the same database or database server that contains the passwords, the usernames and passwords, the user table. So an attack on the pre-login area can actually be an attack on the login page or on the authentication functionality. Cross-site scripting as a social engineering vector. So this is fun. you can do a million different things with cross-site scripting. But one of the things you can do is you can make a little JavaScript dialog box pop up, and it has little input fields. And you can have it say, you know, hello, I am a sysadmin of this site. Please enter your username and password. We're experiencing technical difficulties. We'd appreciate it if you could help us out. So there's a little username field, password field. They enter it. They hit OK. It actually gets sent off to evil.com or whatever the malicious page is. It was pretty convincing, actually. Carryover attacks, I mentioned, putting something in somebody's cart in the pre-login section, having it go to the logged in section, but there are a bunch of other ones. Cookie attacks. So usually a cookie is how you keep session, and that's true whether it's the login session or the pre-login session. If you want to keep their cart details as they're traveling through the site, you have to have some session set up, and there's usually a cookie involved there. So there are cookie attacks. Cross-site scripting allows you to read cookies and set cookies, and that's true for any subdomain or kind of, you can always set the cookie domain up. If you're on a.b.c.example.com, then you can set the domain for .example.com, and it will go for it'll be sent with any request to example.com, c.example.com, b.c.example.com, or a.b.c.example.com. So there's kind of a much larger attack surface for cookies than just the specific domain you're dealing with. Lack of SSL will show you what pre-login cookies there are, and when we talk about session fixation in a little bit, you'll see that if an attacker can set a cookie for a user and then that gets tied to the user's session, then the attacker knows the user's session. Or if the victims say they just go to the site, they get a pre-login cookie, they go, they shop a little bit, then they log in. If the login page doesn't give them a new cookie, and an attacker saw the cookie they were using when they were in the pre-login area that didn't have SSL, then the attacker knows the person's logged in cookie. So then, since that's the only thing that tells the server who's who, if an attacker uses the same cookie that some valid user uses, then the server says, oh yeah, you're Bob. Welcome. Do whatever you want, Bob. Header injection is a great way to store cookies, and if the cookies are 1 and then the next cookie is 2 and the next cookie is 3, you can predict what the next cookie can be. So that's another way that you can kind of figure out what the cookies are going to be. A lot of systems have sort of backwards compatibility features where if you turn off cookies on your browser, the session ID will start floating through the URL. You'll have, in every request, there will be a query string that has session ID or cookie value or whatever equal your session ID. Well, if you make a request to another site, if you click on a link on that page that goes to a different site, the referrer header contains the URL you were coming from, including the query string. So if the cookie's in the query string, then that can be exfiltrated off-site. And always fun, cross-site request forgery and clickjacking. Those are ways to get victims to take actions without their knowledge or consent. In the pre-login area, they still have a session, so you can tie things to their session using cross-site request forgery and clickjacking. And I would suggest looking those up if you don't know what those are, because those are really interesting attacks. I didn't understand them the first time somebody told me about them. It took me a while, because they're a bit involved technically, but extremely simple to execute. All right, user enumeration. This is another big thing that attackers do in the pre-login area. And it's not just the login form itself. A lot of visibility is given to the login form, where you have a username and a password. You put in, Bob and 1234, and it says, I'm sorry, Bob is not a valid username. And you put in Jim and 1234, and it says, that's not the correct password for Jim. That tells you that Jim is a valid user and Bob is not a valid user. And you can kind of brute force through and try to figure out what all the usernames are. And a lot of times it's first letter and last name. So you can do it even quicker if you just use like a last name list. But login form's not the only place you can do it. And it's more difficult in account creation to stop user enumeration. If there's an account creation piece of functionality on the site, and somebody tries to sign up with Jim as their username, and Jim is already a valid user, you have to tell them they can't use that username. How do you tell them that without telling them that Jim is a valid user? It's difficult. So in order to try to stop user enumeration there, what you'll see Google do, for instance, in Gmail, is after you try 5 or so usernames, you'll start having to answer a CAPTCHA as well. And a CAPTCHA is those annoying things you see that it's got letters and stripes through them, and they're all wiggly, and you're like, I can't tell what that is. But neither can computers, is the idea. So CAPTCHAs are kind of the way to limit how many automated requests you can do, so you can't do that user enumeration via a brute force method as easily. Password reset, often it's the same thing. You go to a password reset page, and there's a little input box that says, input your username and we'll email you your password. Well, you input, Bob, and it says, sorry, Bob's not a valid user. And you put in Jim, and it says, we've sent you your password, Jim, or we've sent you a temporary password, Jim. So you can do user enumeration through that too. So account creation and password reset are definitely two huge areas of user enumeration that are often ignored. And I'll just keep going on here. On the login page, SQL injection. So the common SQL injection string that you always see, which is or 1 equals 1, or single quote space, or 1 equals 1, that is, that can often get you past a login page. What happens is the validation is a SQL query, which is select star from users, the user table, where username equals, and then the user input given, and password equals, and then the password given, or password equals a hash, the password given. And if you can break out of those strings and actually change what that query is, you can change it to something that's always true. So then you have select star from users, where username equals X, or 1 equals 1. And then if you put a semicolon and a dash dash and comment out the rest of the line, and now the statement is make sure that you get at least one result back, so that the actual code, PHP code around the SQL statement or whatever, will say if the number of records returned is greater than or equal to 1, then they're valid, give them a session, log them on, everything's good. But a true statement always pulls back records as long as there are some in the database. And so the or 1 equals 1 will get you in and authenticated, but not necessarily as a particular user. Sometimes it's the first user. So SQL injection to bypass verification, that's kind of how it works, a little deeper into it. Cross-site scripting is a keylogger. If you can get a cross-site scripting attack, especially a stored or persistent cross-site scripting attack, into a login page, then you have JavaScript that's executing for every person whenever they go to the login page. What can JavaScript do? Well, it can look at keystrokes. And so you can just have that have that JavaScript running on the login page. Every time somebody goes there, you look at all their keystrokes, you send them off to your other site, and now you've got credentials. So it's kind of an insight keylogger. That's a fun attack to do. We already talked a little bit about user enumeration on the login page. Password brute forcing is not the easiest thing to stop, but there are two varieties of password brute forcing. In one case, you use one username and you go through passwords, and the other case, you use one password and you go through usernames. So if the password rules are uppercase, lowercase, number, and greater than or equal to 8 characters, capital P password 1 is a very common password that's used. If they have to change it every month, try password 2, password 3, password 4, password 12. that sort of stuff. And if you have been able to do some type of user enumeration and you have all the users, then you can make a request for each user using the password of password1. And you'll probably get a greater than 0% of success rate out of that. So you get some credentials, some valid credentials you can use. SQL injection for password gathering. So I told you about the or 1 equals 1 case. You can do one better. you can use SQL injection to union the current statement that's going to be executed with a statement of your own making. And you might get results that come back. You might not get results that come back. If you don't get results that come back from your unioned SQL query, then you can start doing some blind SQL injection where you basically use timing. You make a conditional statement in SQL that executes if you're right or if you're wrong, whatever. And you use the like keyword to say, well, there are several steps to a really useful SQL injection. First step is figuring out how many columns the original query had so that your union statement can have the similar number of columns on the right-hand side. Otherwise, you get a syntax error from MySQL. Then what you do is you look through, if you're in MySQL, you look through information schema dot columns, which is the database and the table name. You look through there for columns that are like %pass% or are like %SSN%, %social%, and you can start pulling out which tables and columns have the information you're looking for. And then final step is you make a union statement with that particular table, pulling out the columns that you're interested in, and you can get all the information. The blind SQL injection, you have to go one step further, and you get information through inference. If the response takes a long time versus a short time, then you know that either your sleep function ran or it didn't run. And if it's a conditional statement that tells you that there is a column like pass, then you can start doing using the like keyword to do kind of a binary search for the table name and continue on in that method. That's kind of SQL injection 101. That's how you actually do it to get data. That's how attackers use SQL injection. Login cross-site request forgery. This is difficult to convince people that it's important. Login cross-site request forgery is where an attacker will log in a victim under the attacker's account. I'm the attacker. I've got a victim. I make the victim make a request to the login page, and I have my credentials in that request. So now the victim is logged on as the attacker. You might think that's kind of against the point, right? Usually it's the attacker trying to log on as the victim, not trying to log the victim on as the attacker. But there are 3 cases where this is really useful, one of which is contests. If you're trying to win a contest, and you can log everyone in as yourself, and guess who's going to win the contest? Say the contest is first person to submit the answer to this puzzle gets a car. Well, if everybody's logged in as you, guess who's going to submit the right answer? It's going to be you. Also, stored data. If there's a site, for instance, Amazon.com, you go into this site and you store credit card information. So if I log on a victim as me, and then I send the victim an email that says, please update your credit card information, they go into the site, they put their credit card information in, they log back out. Well, now I go into the site. They've just added their credit card to my account. So that's another way. And another way is perhaps not as useful, but you can use it to frame people. They hacked my account. Just log them in as you. I've never actually seen that, but hey, why not? On the login page, if there's not SSL for the response that brings the login page to you, then any man in the middle can take that login page and change where it sends the next request to. So instead of the credentials being sent to the server to validate, they're sent to evil.com. So the login page itself needs to be returned over an SSL channel. not just the credentials that you put in and send, the login page itself. And then account lockout. This is one of my favorite stories, eBay. Bidding against people on eBay. So you used to be able to see the username of who could bid against you or who was bidding against you. So you'd go in and you would try to log in as them. You didn't know their password, okay? You try it again. You try it 10 more times. And then their account would be locked and they would not be able to bid anymore. So guess who won the item? That's a fun one. All right. Any thoughts or questions, or is everybody still awake? You guys look pretty awake, actually. Yeah. That is a good question. Can you tell who is attacking your system based on the IP address? You can definitely tell what IP address is attacking your system. Now, that IP address could be coming from somebody's home computer that has been compromised. And so now you show up at this innocent person's house and you say, "You've been hacking our site, time to go to jail." So in that case, it might not work. Or the IP address might be from Romania. Good luck. Good luck, prosecuting or doing anything for that. Yes, PJ? Right. Usually the Apache logs are there, but how long are they kept? Yeah, attaching it to the specific attack. If it's a post request, for instance, then you won't necessarily have the post details. If it's a GET request, you'll probably see it in the query string in the Apache logs. And certainly if you're doing more extensive logging, which is a good idea, then you'll probably have more information and be able to correlate what IP address was doing it. And that is how actually a lot of cyber crimes are solved. People are just doing it from their Roadrunner connection, and that can be traced back. All right, so the login redirect. This is this invisible piece. And header injection is one of the more common attacks here. So header injection, the goal here is to add, for an attacker, to add a header to a response that comes back to a victim's browser. There's a lot to say. So the goal is to add a header to the HTTP response that comes back to a victim's browser. The location header is just one such header. It's one that comes back to the victim's browser after they put in their login credentials. What that location header points to depends on how the login system works. It might be the case that I can send you an email for Amazon.com or some site, and in this email, I include in the query string the redirection location. So that's some input that goes to the login page, is the redirection location. So you click on that, you get the login page, you put in your credentials, you hit submit, it validates it, says good job, it tries to redirect you, and it redirects you to where I wanted you to go, as opposed to somewhere you might want to go. That's how you would change the location header. Header injection actually tries to split the location header into two headers. So the only thing that separates headers is a new line, or carriage return line feed, depending on the operating system. So you'll see the HTTP 200 OK, and then a new line, and another HTTP header, and then a new line, maybe a set cookie header, and a new line. In 302, you'll see HTTP 302 found on a new line, and a couple other headers, and then location, and the location, maybe a new line and some more stuff. Well, if you put in the characters for carriage return line feed, and they're not properly encoded by the web server when they're sent back in the location header, then it can actually make an artificial new line. And so what comes back to the browser has the location header, but then at the end of it, there's artificially a new line and another header put in. So this can be used to do anything that headers can do. Headers can set cookies on a browser. So header injection, one of the primary things you use it for is to set cookies on a victim's browser. And setting cookies, sometimes you'll see a cookie that has a username in it, and then there will be like an account page that says, hello, comma, username. That username is sometimes pulled from that cookie directly. So if you can put in a cookie that has some malicious JavaScript, then you can actually use the cookie as a cross-site scripting vector. So when it says hello or welcome, comma, and then the contents of the cookie, it's the contents of the cookie including your cross-site scripting vector, the JavaScript you want to execute. I actually just found that recently. It's fun. Predictable session tokens. So the login redirect, again, is where the session cookie is set. And so session cookies, they come in all shapes and sizes. And sometimes they're just an incrementing number. Sometimes they're the time of day, like the date, some type of timestamp. Sometimes they're a hashed version of an incrementing number. So if they're predictable, then you can log in as a regular user and see, oh, I got 5. I'm going to wait 10 minutes and then try 6. So if the session token is predictable, then you can guess what a logged in user's token will be. And since that session token is the only thing that determines, as far as the server is concerned, who's who, you are 6. Forced redirection, I talked about that a little bit with the location header mucking about. You can send them off-site, or you can send them to the site to a page that actually takes an action. So this is the cross-site request forgery example. So the original example I gave was to the mail/inbox.php with email ID equals 11 and action equals mark as read. Well, action could be delete as well. And if an attacker can control where the redirection will go, and there's some GET request that takes some action like delete all the emails, then an attacker can force a victim to, once they send their credentials and they get validated, they get redirected to a URL that takes an action. That action might delete their emails, that action might change the direct deposit information, that action might make the attacker an admin on the site. And you got to have SSL all over the place. Login redirect is a very important place because the session cookie is being set and then being sent. And that cookie is all that tells the server who's who. So if an attacker gets it, the attacker is the victim. JavaScript or meta tag redirects are a little bit hairy because they're usually written dynamically based on what would have been the location header. So login page always gets the input of where the user was trying to go, and then they have to redirect that user there somehow. If they use a meta tag or especially a JavaScript redirect, then they're putting user input into JavaScript, executing JavaScript block. And there's a lot of funky things you can do inside of a JavaScript block. You can do things like put a closed script tag and then continue writing HTML. You can open up another script tag. Even if you put a closed script tag into a JavaScript quoted string, it will close the JavaScript block. The browser will see that as the end because the browser has two separate interpreters, one for HTML and one for JavaScript. And so it just reads through the HTML and it sees, oh, here's a JavaScript block between this script, this open script tag and this closed script tag. And so I'll just execute the JavaScript in there and then I'll do whatever happens after that script tag. So if your user input goes into a JavaScript block, you can put a closed script tag and actually break out of the JavaScript block even if your user input is in a JavaScript quoted string. You'd think JavaScript quoted string, that's just data. Not necessarily. It can be HTML to break out. So you can get some cross-site scripting attacks in that way. All right, I've got about 5 minutes left, so I'm going to go through the logged in section and log out and conclusions. I'll just kind of zoom through here a little bit quicker. In the logged in section, if you get cross-site scripting attacks in there, you can use a framework called Beef. Really cool framework. Basically, it's almost like malware on the victim's browser. You can make requests as them. You can have little pop-ups show for them. It's like complete control over that domain. It's really cool. But it's one cross-site scripting hole. It's full control. You can use cross-site scripting to try to get the session token. Again, document.cookies is how you get that using JavaScript. You can send that off anywhere. SQL injection, you might not have a way to directly attack the logged in area. You might not be a valid user. But if you can get a victim to make a request, an unintentional request that contains a SQL injection payload, then you can cause them to make the SQL injection attack. And then you can do whatever you can do with SQL injection attacks, which gets advanced. Cross-site request forgery and clipjacking, another great way. Even if you don't have access, you can still make valid users take actions on the site and do things for you, change people's direct deposit information to your own, do all sorts of stuff like that. SSL, if you don't have SSL in the logged in area, then each request, which contains your session token, is sent in clear text. Your session token is sent in clear text. If an attacker gets that, they can masquerade as you. Sometimes the logged in area doesn't actually require, it doesn't actually check to see if you're logged in. It might in 90% of the pages, or 99% of the pages, or 1% of the pages. Sometimes that's the case. And yeah, it's just, there's not like a consistent framework that's used on every page to make sure somebody is actually authenticated. And we'll skip through, we talked a little bit about forced lockout, but you can also log people out by sending them to the login page. AJAX hijacking is very complex, and I'll talk to you afterwards if you want to talk more about that. Logout, again, forced redirection. There's a redirection step, so you can send people potentially where you want. Header injection using the location header, same idea. Inadequate logout and session reuse. Sometimes all the logout does is sends you to the non-logged in area of the site. It doesn't remove the cookie. It doesn't destroy your session. So you're still logged in. An attacker can still get in as you if they can figure out your cookie. Conclusions. Login and authentication can't easily be segregated from the applications that use it. So single sign-on is kind of hairy, because if there's a SQL injection on a pre-login area or on a different application that shares the same database server, you might be able to get the passwords out of that database server from a SQL injection in a different area entirely. So having one group that works on login and other groups that work on other sections, if they don't have any communication, then you can have some bleed over attacks there. Pre-login, subdomains, parent domains, sister domains, they can all affect login and authentication functionality. This is through the cookies not being scoped too broadly, for instance, or not having SSL and having bleed over attacks. User enumeration. Protection applies to login page as well as account creation and password reset. Can't stress that enough. I see that all over the place. Cross-site scripting and SQL injection are pretty much game over. Stopping brute forcing of passwords is difficult, so make passwords difficult to brute force. Use password rules, make difficult password rules. You can even try to make sure that there aren't actually words being used, because a word is a really easy thing to find with dictionary attacks. JavaScript redirects can lead to DOM-based cross-site scripting, hard to protect against. You have to update the session cookie during the redirection step. Otherwise, if anybody knows or can set the pre-login session cookie or the cookie on a person's browser before they log in, if that cookie is their cookie after they log in, then an attacker can have knowledge of that. So session fixation is big there. Use cryptography for security-related tokens. You have to use real cryptography, not made-up cryptography. People can figure it out. Watch what goes into the URL, because this can go off-site in a refer HTTP header. force users to use cookies. There's no excuse anymore. Nobody's really using links to do their online banking. And so the backwards compatible functionality of having a no cookies setup, not really a valid use case anymore, in my opinion. Using a framework to approach problems like authentication, HTML output, SQL injection, cross-site request forgery protection, having an opt-out sort of situation where you have to turn that sort of protection off is more the way to go. Otherwise, you're going to have some percentage of the sites not covered, of the pages not covered. AJAX might require cross-site request forgery protection for GET request too. That's the AJAX hijacking stuff. And expiring a session cookie is not a sufficient logout procedure. You also have to destroy the session. So I think we're out of time. So any questions, just come on up and I'll be happy to talk about stuff. And then I'll be riding the bull.